All right. So all I'm doing is I'm just setting up a list of points, and we're going to use these points as a set of examples as we go through each of these different iterations of the command set. So I've got a series of points, and I'm going to do a second move command, and you'll see why in a second, but I'm just going to go ahead and create a second set of points with the same series, except moved in the y direction. So if we plug a panel in, we can see how we're moving this stuff. It's a series of vectors moving 1 point by 0, 1 point by 1, 1 point by 2 in x and y. And then we can just see what we're getting out up here. And again, you'll see starting from 0, 0, 0, we've got 1 point moved by 0 in x, by 1 in x, 2 in x, and so on. So that first move gave us our horizontal set. The second move moved each of the first move set in the y direction. So instead of getting a straight vertical line in y, we have a diagonal line across. So I'm going to use a point list command, and it's just going to display the order of points in the list that they appear in. So if we switch these up and just look at this panel output from the second move command, then a slider, we can change the size. It's numbered these points in the order that they were created. So if we were to draw a polyline, we would see that it would start at 0 and end at 8. And we can go ahead and do that. Going to ask for a set of vertices, so we'll give it these points, and it'll draw a line across. So we can see that that polyline has an endpoint at 0, at the 0 point, or a start point at the 0 point and an end point at the 8 point. So if you haven't figured it out yet, if you right-click on a component output, it gives you a series of options to either reverse the list. These are all list commands. You can reverse a list, which is just going to flip everything around. See, now the 8 is at the top. You can graft a list, which is going to split each individual element of the list is going to be split off into its own sublist. So now we have 15 or 10 sublists. So the other one that we're going to look at first is the flatten command. And if you take the list and you flatten it, I'm not going to do anything right now because they're all in their own, they're all in one list. But if you've grafted a list, then flattening it will put it back into the same list. It's pretty much the same as flattening a layer set in Photoshop or Illustrator. It's going to put everything into the same list or layer. So let's just come down here, and you can graft with a graft command, or you can just right-click on things. The graft command gives you a little bit more control and shows you exactly what you're doing. So we'll use that for now. I'm going to leave this stuff up and just copy it down. Go ahead and hide it. And I'm going to graft this first move command. So if we graft the first move command, it's going to put every point in its own separate list. We plug that graft into the second move command. Look what happens. So remember that when Grasshopper has a list, it's going to iterate through until it has nothing else to take. So this sublist means that every single component in this first list is going to be moved 10 times vertically, and every one in the second sublist, and everyone in the third sublist. So, and that's shown, you can see that in these numbers right here. We have a list in the graphed list. The entire first row is 0 because we grafted that. So we have a sublist where all of the elements are 0 and one where all of the elements are 1. So now if we plug a polyline in here, we're going to get a line. We turn the points off. Going to get a line from each 0 to each 8. So grafting takes one element and puts it in its own sublist, or takes each element from its list and puts it in its own sublist. We can compare the graft to the grafted move, and you see there are 9, okay, so there are 9, not 10, 9 items in each list or sublist in the graft command, or the move command. So it's taken each one of these points and moved it in the Y direction according to the series that we used. Now, if we wanted to do something kind of crazy, we can move them again. And now, if we move it the same amount by the unit Z, believe it or not, it's going to do exactly what you think it is, and it's going to take every single point. It's already grafted, so it's going to take every single one of these points and move each point vertically 1 through 8 units, or 0 through 8 units. Or it should. So we had to regraft it because we had a list with more than one element in each sublist. So now the graft has a bunch of different single item sublists, and we have a cube of points. That's the graft command. The flatten command does pretty much the same thing, or the opposite thing. I'm just going to copy this down again. So if we want to flatten, we can take what we've got here with our 2 move commands and we can run a range up, and I'm going to use this slider that we have as our input for a range set. I'm going to use a panel as a data entry this time. So I'm going to set up a domain using a panel, and I'm just going to use -1 to 1, and I'm going to hit OK. You cannot hit enter or it won't accept it. So it's going to read this as a data input and a domain input. All right, so there we go. I'm going to use a polygon and give it a couple of sides. going to find the center. Yeah. Sometimes psin brings it up, sometimes it doesn't. When in doubt, try again. I'm going to use a vector between 2 points to begin to create a set. I'm going to take the result from our move command up here, the second one. I'm going to use that as the endpoint for the vectors. I need to put my graph back in here. Yes, for sure. Where did I lose you? Okay. So all I'm doing is I'm going to set it up so that these polygons are going to move to each one of the points that we had created. So this first bit is just what we were working on a minute ago, right here. It's the first part of this. The second part is I'm just setting up a polygon set, this square guy right here, finding the centers, and then creating a vector, which I'm going to use as a movement vector. So when we come over here, I'm just going to show you guys the vectors. So the vector display is going to ask you for an anchor point for the vector preview and then the actual vector. But see all the vectors we've got? So those are the vectors we're going to use. They're going to start from the origin, and each one is going to move to one of those different points that we have up here. Does that make a little bit more sense? Okay. You tell me where I lost you. Okay. Up here? All right. Let me turn this stuff off. Okay. Lists are a pain, but they're important. So when you have a data set in Grasshopper, it's going to operate just like we talked about a little bit last week in lists. It's going to see if you have a set, and if you have a set, it's going to apply the operation to every element in the set. If you have a single point, then it's going to move it through the series. So originally we had one list with one series, so it gave us one list out by the series command. The series is going to output this list. So when you have a series command, you're asking it for a start. It's asking you for a start point, which we're just going to let be 0, a step size, and then the number of steps. And it's going to give you a series of points or a series of numbers that relates to that step size, that list start, and the list size. So everything that Grasshopper outputs is a list. So we use that series to create a set of movement vectors, which are going to define how we move a single point. So if we have a single point and we're moving it by a list or a series, it's going to move that single point once for every element in the series, right? So if we move that one element by each element in the series, we're going to get one new point for every element in the series. If we do that again, we're going to move each element for each point in the series, right? So the first element, because it's all in one list here, so we have one list and one list, so it's going to move 1 to 1. Just so you guys can see that. There's one list and there's the other. So the first point is getting moved none. The second point is going to get moved 1 in the Y direction. the third one 2 in the y direction because this is our unit vector y right here to get that. When we graphed a data set, you're going to get each list or each element split off into a separate sublist. So if you have one element in the sublist, it's going to apply the entire series to each element and then move to the next sublist. So when we do that, instead of getting something diagonal like this, we're getting a whole array. So what we did here is we moved each element in the first list by none. Then we moved each element in the second sublist we moved each element in the first list up 1 and then 2 and then 3 on. And then it moved and iterated through the next sublist and then the next. So each element, if I can get it to display, is being moved within its list. So when we get our output, we have 8 different sublists. And we can scroll through those. We have 8 different sublists that have been created by iterating 8 sublists through a series of 8 moves. Does that make a little bit more sense? Yeah, so those are panel commands. You have to put them in, and then so the panel will receive, like we talked about last week, the panel will receive whatever you put into it. And you can either edit it and use it as an input, or you can put whatever you want into it. See, our unit vector just gave us a bunch of different movement vectors, which are the same as what we had on the other side. No. It's either abbreviations or images. And oh, you're talking about the entire words. Yeah. Yeah. So it's just display, draw full names. Okay. Now we can spread everything out so you can actually see it. There shouldn't be anything else behind it. But yeah. So the graph command works by breaking everything down. The flatten command does the opposite. So if we were to, let's just say, flatten our graphed list wherever it went. And put a panel in there. We're back to having just one list with all of these elements in it. So it's the exact same list set. It's just broken or simplified into a single list. So all of these data points are going to be the same, 1-to-1. But instead of it being in many different sublists, every data point is in the same list. So the best way to think about that is to remember that the flatten undoes the graphed. All right. So does that make a little bit more sense? And Nick Sinsky, in that set of YouTube links that I gave you all, has a really good video about this kind of thing. Sometimes it's easier to think about it that way. I'm a math person, so I think about it like sequences and series in math, which I know probably doesn't help a lot of people. But the best way that I had it explained to me was thinking about it like the graft undoes the flatten, the simplify undoes the graft. So they all work together. And they're altering the way that the data is arranged, not the actual data itself. So it takes some playing with and some figuring out. And I'll give you the notes page that we're working on that has all of this information in it and a little bit of explanation about each command. But it is really something that you're going to have to play with and figure out what works best for how you understand it. Because you can sit here and look at these and listen to me talk about how all of these lists work all you want, but you're going to have to say, okay, wasn't the one I wanted to change. If we drop that down to 9 elements instead of 100 something, you've got 3 elements here, and you have the same 3 elements here, just each element is in a separate sublist. So it's going to, when it goes through, treat every sublist like it's its own list. So instead of applying the first operation to the first term, the second operation to the second term, the third operation to the third term, it's going to apply all 3 to the first and iterate, and then all 3 to the second, and then all 3 to the third. So it will repeat itself until it's done with all of the elements in the list or the sublist, and then it'll move to the next one. And the same thing here, since we moved everything. Here are 9 points iterated through all of the zeros, all of the ones, all of the twos. 0, 1, 2, 0, 1, 2. Does that help seeing it broken down into a smaller subset? All right. So a little bit more practical maybe, because cubes full of points are kind of cool, but they don't necessarily do anything for us right away. You're going to need them for the assignment. But to help you visualize what we're doing, we can look at a set of polygons and how that set of polygons changes or moves based on how we flatten or graft the set. So, like I said, I've just got the same series command set up with the same set of movement. So we've got an array of points. We'll make it 25 points. Note that Grasshopper does start with 0, not 1. So it goes from 0 to 4 for 5 points instead of 0 to 1 to 5. And what I'm doing here is I'm setting up a domain so that we don't scale or don't move or scale more than what we have. Grasshopper gets a little bit picky if you try and do more operations than you have elements to operate on without having it listed like that. Or it'll start stacking things up, which isn't really what we want. And then I've drawn my polygon that I'm going to use. I've found the center of the polygon and I've created these vectors. The move command works off of a translation vector. It's a motion vector. And we're going to use this vector that we gave it a start point from the center of the original polygon and an endpoint at each of these points that we had created. We're going to use that to move the polygon to each of those points. If we hide the original, we'll hide the vectors for now. Polygon may be a little bit big for what we're trying to do. So I'm just setting the min to 0 and the max to 1 and setting it to the real numbers instead of the integers, so I have a little bit more control. So there you go, we've got a point, or a polygon on every point, just by doing that same move command and using the vectors. And we could have set up the same thing we did up here with the polygons. We could have done exactly the same thing based on the center of the polygon and moved it with a series once in X and once in Y. But the vector is going to be a little bit more effective and efficient, and there are less things that can go wrong right there. And then we'll use a scale. We'll give it a geometry. We'll give it a scaling factor, and we're going to use our domain or our range that we set up, so it'll be a variable scale. And now it's not happy because it doesn't have a center point, and it's going to be confused about that, and there's a 0 scale factor there. But we'll give it a polygon center point. But we have to use each of these original points because we didn't move any polygons here. We could find the polygon centers from the move command, but we know that they're already centered on the points. We can come back up here and just use the points as our centers. So the 0 command, the 0 element of this domain that we set up, is going to force the scale command to fail because you can't scale anything by 0. But you can see that instead of failing the entire domain or the entire command, it's just going to fail the set that it would have scaled to 0. And if we want to look at that set, we can look at our panel right here and see those are our 5 scale points. Because we set our step size, we set our count, and we use the difference between the step size and the count for the number of steps, which gave us 5 steps for 5 sets, or 5 series. So if we flatten this, realize really fast that we have 2 of these dotted lines, which are grafted or grafted data trees or lists. So instead of, in one list, and the panels are not very helpful about what polyline curve is defined as, but you can see we've got this different set of sublists instead of one continuous list. So it scaled each list. It didn't scale variably for each element, it scaled variably for each list. But if we plug in flatten tree, which has 2 T's and no B's, going to give us a single list with all of the elements in it. So it's a single list with all 25 elements in it. And then another one down here. We can plug these flattened lists in. Happy. So I just changed that domain to get rid of the 0 in it, so that it wouldn't do anything too wacky. And my original polygons are like they're showing and they shouldn't be. There we go. So now each element is scaled. You can see each polygon is getting larger as it goes through. And if we want to do a point list right here, we've got it already. Just plugging the same size as before in the tree, the flattened list in. We can see how it's going through those steps. So it's starting at 0 and moving through all the way up to 24. So it will apply to the 0 first, and then the 1, then the 2, and on and on. You guys have any questions about that? What's up? Yeah, I'm going to put this whole Grasshopper file on Canvas too. Yeah. Did you all see that the first Grasshopper file is on Canvas? Okay. You have to, yeah, it won't run. You have to drag and drop it into Grasshopper once you open Grasshopper. Windows doesn't know what to do with the file type. Let me pull up Canvas really fast then, since we're here, and I'll address that. So on Canvas, you should have a discussions page. And in the discussions post or discussions tab, there are 2 discussions. One is the updates and information, and it has all of those links to both Nick Sinsky's videos and a link to the Grasshopper and Rhino tutorial homepage, as well as the weekly lectures and notes. So it has the lecture notes and the lecture. And the Grasshopper file apparently did not get up there. I will take a look at. The Grasshopper file is up there, it's just not linked. It's in the on the files page, which you all should be able to see all of these. But I will, there you go, it's in the lecture notes now. I'll take care of cleaning that up a little bit. But it is all up there. You should be able to see it. If you can't, let me know. But when you download a Grasshopper file, Windows doesn't know how to run it. So if you have Grasshopper open, you can just drag it into Grasshopper. It'll open the file. And if you have more than one Grasshopper file open, you can click on the little tab up here, and it'll bring up a drop down and let you switch between the 2. All right. So we can use this same base with the move, the grafted moves. We're going to look at polylines for a minute. I know I'm kind of flying through this, but there's a bunch we have to get through today, and we're already behind because of the schedule. So I need to make sure that you all have what you need to get the assignment done this weekend. So if we've got this move set up, we talked a little bit about how polylines work. I'm just using a plines command bring it up instead of searching for polylines. It's asking you for the vertices, and we're going to use this geometry point set as the vertices. So if we put our point list in here, and a slider, we can see how each list is set up. And remember, it's grafted. So we have a different set of sublists. The polyline command is going to honor those sublists. So it's going to move between each sublist and not cross over them. So the polylines went from 0 to 4 for each sublist. If we flip a set or a list, it's going to reverse it. And that is the wrong flip command. We need flip matrix. So the flip matrix, a matrix and a list are roughly the same in Grasshopper terms. So we can use that flip matrix. And you can see that from this original, we went from moving through the X and the Y, or moving Y after we moved X to moving X after we moved Y. So this first series has become, where'd it go? There we go. Instead of 0, 0, 0, 1, 0, 2, we have 0, 0, 1, 0, 2, 3, 4. And the second list did the same thing. They flipped. So 1, 0 is now 0, 1. 1, 2 is now 2, 1. So the flip command is going to just reverse the order of the points. And if we do our polylines now, let's look at points for a second. After we flipped it, do you see that? We went from the zeros along the horizontal to the zeros along the vertical. We can put it back in the top view. Now what happens if we use a polyline on the flipped matrix? It's going to do the opposite that the original one did. So it's still following the same logic, but since we flipped the orientation of the matrix, it's going to run horizontal instead of vertically. If we graphed the polylines, it's going to fail. It's failing because we have insufficient points for a polyline. Because when we graphed a list, we get a bunch of different sublists. If there is only one item in the sublist, the polyline does not have enough data points. You need at least 2 points to create a polyline, or any line. But since we only have 1 point, the polyline command cannot run within each sublist, so it will fail. We can use a partition list to begin to subdivide a list into a different size of sublist. So to do that, we're just going to flatten what we had up here so we have a single list. And then we can say maybe we want our partition size to be, I don't know, however much we moved it by originally. So let's say 5. So our partition size is going to be 5. And our list is our flattened list. We look at it, we have just what we would expect. We're going to have 5 lists of 5 elements, or points in our case, in each list. Just going to come up here and copy my points list down. Maybe hide the other ones so we can see. You can see it did the exact same thing that the polyline itself did, which we would expect because we have this set of lists based on our base number. So if we moved everything 5 times, we'd expect to get 5 elements in each list here. And then the partition size has the same size. And you can begin to change the list size up, and it will do its best to subdivide it. But if you don't have enough, it'll give you 3. Like here we have 3 with 7 and then 1 with 4. You can give it, 12 or 18 with a math major and I can't divide. We have 25 points, so it would be 12 with 1, or 12 with 2 and 1 with 1. You can start to change that up, and you can see the points are going to be reflected in real time as you move through it. So if we were to plug a polyline in here, it would start at each 0 and run to each 5 and then stop. Start at each 0 and run to each 5 and then stop. Let me turn this one on. This is going to be important when you're looking at the assignment, to remember that you can change the length of a list set. But note that it's failing on this last component because there's only one point in the data set. We're back to a line. So the other command that's going to be useful is an item or index item, list item, and it will let you pull a specific element out of a list. So we have our 25 points. We're going to plug this flattened tree is just our base list, or our base set of points again. I just have them flattened back into one single list so we can manipulate a single list instead of a set of sublists. So its default is going to be to index 0 and to wrap it, which is fine. But see, with 0 indexed, it selected that first point. We give it a slider into the index. At 5, it selected the 5th point. 0, 1, 2, 3, 4. Remember how it wrapped? 5. You can choose which point you want to select. We'll just let it select 6. And I'm going to use a point, data point, to hold that element. So I've used a list item command to index a specific item in the list and then pull it out so I can manipulate it. I'm going to graft my data tree back, and I'm going to just use a plain old line between 2 points. I'm going to give it the start point, I'm going to give it the end point, and it's going to starting at that point because we grafted our list. Remember, when we graft the list, we get a subset for every element, or a sublist for every element. Starting with the point that we selected and pulled out as the start point, it's going to draw a line to each and every additional point. And if we move this point, that base point is going to move parametrically with it. Does that make sense? The most You're going to use graft and flatten more than you're going to use flip, simplify, reverse. The simplify is going to do the same thing that the flatten does, more or less. The cull command, the cull pattern command, and the cull index command are the last two that are going to be really important for this assignment. So given right here, given a list and a set of indices, it's going to cull out or cut out that indexed set of points from the list. I'm going to come back up here and plug our tree into our list. It hasn't been given anything to cull yet, so we'll take our number slider and use that as our input. And then it cut out, see everything that's highlighted green is selected. It cut out that third point in the series, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? And then to visualize that, we can just use a polygon. That's it. And a number slider for the radius. We'll just steal that one for the segments. We can find the centers. Again, we're just going to do that same vector 2 points that we did earlier instead of having to call on all of our points. I'm going to use the first polygon center for point A and then the list for point B. So I'm taking all of the points that we didn't cut out and using those as the movement destinations for the polygons. You plug it in there for the vector motion and the geometry. And then we have cut out, we've moved to every point except the one that we cut out. So the culling components are going to exclude a point from the list. Remember, you can use the point list command to visualize numbered points. And it shifts, the cull index is going to shift so that you don't have an empty component or parameter in your list. So there's the 7th point that we cut out, or 0.7 that we cut out. It's the 8th point. You can always use that points list command to help you see what you're working with and what is actually being included or cut out based on how Grasshopper is numbering things. Does that part make sense? Or did I lose you? No, because I'm here to make sure that you understand what you're doing so you can do the homework. Does this make a little bit more sense than the graft? Yeah. So the graft command is one of the hardest things to grasp about. Like the whole point list thing is one of the hardest things to grasp about this class. And, you know, sitting there last night working out how to explain it to you all is one of the biggest challenges for me because it was one of the things that I struggled with when I was taking this class. You can use the graft command and then just play with it to figure out what it does where. Knowing how to use this cull index command is going to be really important. It makes a little bit more sense, I think, for people because there are actually numbers associated that you're looking at and that you're seeing instead of just this list of things in a yellow box. But just remember that you have to flatten this list. If we don't flatten it, we're going to have a bunch of different little lists, so we're never going to get up to something that we can cull out of. So you need, if you're working with the entire list, it needs to be flattened. If you want to move every piece individually without having to go through the entire list, it needs to be grafted. It's a pretty good rule of thumb. So the other one, we group this, we're almost out of time. The other one is a call pattern. And we'll use a set of Boolean inputs. So Boolean inputs are true, false. And it's going to take a pattern, and it's going to call based on that pattern. So if it's false, it's going to not include them. If it's true, it will include them. So here, the default for the call pattern is false, false, true, true. Over here, we can see that false, false, so not in the resultant list, true, true, false, false, true, true. And it just keeps going through that pattern until it reaches the end of the list. So we can use the same Polygon stuff. I'm just going to copy it down. And have it move to the called pattern. You can see again, false, false, true, true, false, false, true, true. It lets you skip a number of points in the series repeatedly. So you can do that in a couple of ways. You can right-click on the component. You can do set multiple booleans, and it'll give you a text editor. And each entry has to be on a separate line. So if we do false, true, for instance, then commit changes, it will change. So it's false, true, false, true, false, true, or false, true. There we go. If Grasshopper likes me today, you can use a multi-line entry box, and you have to make sure that it's good with multi-line items. Okay. And it should accept that as a call pattern. There we go. You have to make sure it's the multi-line is unchecked so it doesn't wrap. And it'll accept that as a pattern. So you can use that, and again, to begin to play with the logic of it, you can just play with which components or what input you're using for the booleans to see what it does. And here, false, true, true, false, false, because we're going back to the top of the list here. True, true, false, false, true, true, false, and back to the top of the list. So we'll continue to iterate through that list until it reaches the end. So we can use a shift list command to slide the points. It's going to offset all items in the list. So I just plugged our big list all the way back up at the top into the shift list command. And the shift offset is going to be 1 by default. You give it a points list. And the points. What we're doing here is we are changing the start point. So if you shift it by 0, the 0 is still going to be where we're used to it being at the point, or the base of our array of points. It's going to shift forward. So the 0 moved to the 1 to the 2. And note that the last point wrapped back to the 0. So our last point, as we move through this, the last point will continue to move up in position towards where the 0 would be, so it will wrap to the start of the list. So you begin to shift individual lists. And the last thing go ahead and hide all of this stuff. The last thing is going to be a weave command. And that's going to do pretty much what you think it's going to. It's going to take two lists and weave them together. So it'll bring two lists into one based on the pattern that you assign it. So to get our two lists, I'm going to create another series of points. Construct point. I'm going to move it by a series in X. I'm just going to give it 5 of them. And I didn't give it a vector, so it's not happy. So I've got my 5 points there. I'm going to move them again. I'm going to do it in Y this time. I'm just going to do it by 2. So I've got now 2 sets of points, 2 lists of points. This is where the weave command comes in. So it's going to ask you for a pattern. 0 and 1 are going to be the 2 lists, stream 0, stream 1. So we'll take our first list and put it into 0, our second list and put it into 1. The pattern is going to repeat 0 to 1, 0, 1. So that's the order it's going to take things from the list in. So if we select it, I'm going to show you because I have the other 2 turned on. It has used all of the points that we created. But when we list the points, we can see that it took one from the first stream, one from the second. First, second, or 0, 1, however you want to think about it. 0 and 1, 0 and then 1. So it began to weave those 2 lists together to create a single new list. And if we take a panel, you can see that that's exactly what it did. 0, 0 in the second list, 1 in the first list, 1 in the second list. So those are the commands that are going to be really important for getting the assignment done. I was going to talk about path mapping a little bit, but I think we'll leave that until next week. So I can take up the last 10 minutes or so answering any questions that you guys have. I know that this is a lot, and it's kind of all over the place, but sitting down and playing with it will help. You all have my email, you know how to find me or any of the other TAs. I mean, we're in the lucky position of all of the other sections having already finished this assignment. You also know where you can find your classmates who may be able to help and explain it in a different way or help walk you through it if you can't come to office hours. Do you guys have any questions or anything that you want me to go over again? So there's a spreadsheet, a Google Drive spreadsheet link on Canvas. You should have all gotten an email with it. We would appreciate it if you sign up there. But I am in the first bay of the 4th year studio bays over by the library. on the second floor from 10 to noon on Wednesdays. Yeah. The other TAs might have time tomorrow. I have classes all day, so I won't be available tomorrow. You can email me and we can work. Thursdays are generally all right. But it's in the afternoon on Thursdays. Yes. You can do whatever you want. If it's questions that you need answers to, I'm going to suggest that you bring your laptop and your Grasshopper file with you so that we can work on your Grasshopper file instead of me working on something and then emailing it to you. But if it's just, oh, I have a question about this, can you explain it? Then yeah. Whatever helps you work it out for yourself best. But I would definitely recommend, there are a bunch of videos floating around from McNeil, from Nick Sinsky, and the Grasshopper webpage has an explanation of how to use each component as well. And make sure that sign-up sheet makes its way back to me somehow. Bless you. Do you guys have any other questions?